طيب بسم الله الرحمن الرحيم. إن شاء الله.
We should watch the videos.
Watch the videos, yes. So last time we talked about the taxonomy or the classification of networks from a physical standpoint and a logical standpoint. From the physical standpoint, we talked about the network that cover a specific geographical area, and we divided the types of networks into LANs, WANs, and MANs, and we talked about the difference between each of these types of networks. We also talked about three categorization or three classes of networks from the logical point of view. We talked about intranet, extranet, and internet. So we talked about the intranet, that covers many sites distributed geographically in different locations, yet the intranet provides like some private communication inside this network which is not exposed to the internet. And extranet, the difference between extranet and intranet is that the extranet is owned by different organizations, two or more organizations, and it facilitates, again, private communication within these organizations. Today, inshallah, we talk about very important features. So when we design any system, we build and design each piece of the system, but we have to have a global picture about what features do we need to be existing in this system. In the internet, there are some end-to-end features that need to be in place. And according to how much you support of these features, your network will have a better performance. Some of these features are fault tolerance. So we'll talk about what fault tolerance is. We'll talk about scalability and what this is. We'll talk about quality of service and security, which we don't know what it is, but we'll talk about the different types of security. So fault tolerance itself is a feature that talks about the ability of the network to work, to operate under errors. Okay? So once you build a network, okay, the user will start to acquire some services from the network. Okay? So what if there is any problem in the network? Will the network still operate? Well, the more problems that the network will be tolerant to, the more efficient this network is. An example, in the past, we used to have the landlines, telephone landlines. And the network that supports the landlines is what we call circuit-switched networks. By circuit-switched networks, we mean that the network has a set of switches. Okay? So at the beginning, when you start calling someone, a circuit gets established end-to-end from the beginning. And it's fixed throughout the entire call, even if you are not saying anything. Okay? So even if you call someone and put the phone away, you're still consuming that circuit. This is the main reason that when we do phone calls, we get paid by time. Okay? Unlike when we download files or something, we get paid by the bits or by the bytes that we utilize. We'll talk about why. So for circuit-switched networks, as long as you have established the communication at the beginning, you are consuming that circuit even if you're not doing anything. Okay? So this has some advantage when we talk about quality of service. This guarantees the quality of the voice. Okay? We'll talk about that in details later. But the problem with this is that this is not very fault tolerant. Why? If there is any problem in any of these switches, we cannot tolerate it. The whole call, the whole communication is down. And you have to re-establish everything from scratch, which will take time. Okay? So this has an advantage and disadvantage. Advantage from the quality of service point of view, because it guarantees the quality of the voice. Why? Because the network has reserved everything for you beforehand, before you start communication. Okay? But the problem is fault tolerance. if there is any problem along the path, then the whole communication is down. You have to start everything from scratch. So fault tolerance talks about the ability of the network to adapt itself or to readapt itself to different types of errors. And the more errors the network can tolerate, the more efficient and the more performance you get. Okay, so that's fault tolerance. For packet switched networks, we do not establish any circuit. If you want to send some information, we divide it into what we call packets, and we send these packets to the network. One packet may go this way, another packet may go this way. We don't know. We cannot guarantee, okay, that all the packets will go along the same path. Why? Because there is no circuit established. No circuit is established. No session is established end-to-end. So the good thing about this is that you don't have to establish a circuit before you start communicating, because it takes time. It takes time to go along all the switches or routers along the path and reserve these routers for your code. It takes time. Okay? So here I don't have to spend that time. I can just communicate right away. I send packets, and these packets, one packet may go this way, one packet may go this way. I do not have any guarantees. The problem with that is some packets will go in a longer path compared to other packets, right? So this will not give you the quality of service that you are wishing to have. Why? Because at the receiver side, some packets may be delayed, some packets may arrive early. Okay? So for me as a receiver, I have to wait for all of them, which might take time. So the end-to-end delay that you encounter or that you experience is high, right? And that affects, for example, if you have video streaming, it requires very short delay, right? If you have long delay for video streaming, what will happen? You watch a movie on YouTube and you see like some pause. So the video will pause, will freeze. And for you, this is not a good experience. So for video, you need very small delays. So packet switch networks will not necessarily give you the type of quality that you would wish to have, especially for delay-sensitive applications like video. But let's look at fault tolerance. Let's look at fault tolerance. Because each packet is sent individually and I do not have any circuit reserved before I start communication, if this router is down, what will happen? So automatically this router will get notified and then will reroute the packets through this path. So the error that you encounter is almost negligible. Maybe one packet will be lost, which will be very easy to fix, rather than just the whole circuit established is totally down and you have to re-establish everything from scratch. This will take sometimes tens of seconds, which for the user it's a very bad experience. But here, fault tolerance is high because the path is per packet, not per session. Okay? So if anything is down in a as low as maybe 2 milliseconds, I can just recover from this error in 2 milliseconds. Versus in circuit switch, you may take tens of seconds, okay, which will result in very bad experience for the user. So this is fault tolerance and how you support fault tolerance in packet switched and switched networks.
Why does the quality drop happen? What exactly causes it?
Because the packets go through different paths.
It's simple.
Okay. If you have a line of cars and you want to send these cars in this order from one location to QU, okay, each car goes through different paths. What is the possibility? Some cars will arrive before the others. Okay, so they will arrive in different order, and some of them may take very, very long time. At the receiver, which is in our case QU, I have to reorder all these cars again in order to take them in the same order that I sent these cars to. So that affects the quality. Okay? So the end-to-end delay will be in general very high. Versus circuit switch, before everything goes through the same, it's like a pipe. If you send water through a pipe, it will go smoothly until the end because everything is reserved. Okay? Scalability. Scalability talks about the ability of the network to work efficiently. Okay? So it's the same like fault tolerance, but under higher number of users. So the more you increase the users, the assumption is if the number of users increase, so the network should actually, start choke and the performance should go down, right? Scalability talks about the fact that when you increase the number of users, both the new users and the old users will not be affected that much. And that's a big challenge. Because technically, as you can imagine, the more users you have, the more resources you need from the network, right? So how can we scale the network so that when the number of users increase, the network performance experienced by all these users is more or less the same? So that's another feature, and the way that they support this over the internet is through two things. One is the routers have to be intelligent enough that they need to provide different behavior to the different types of traffic. So some applications or some users may actually get more bandwidth compared to other users. Why? Because this user paid more. So we have to take into consideration some other factors in order to provide scalability. So we cannot say that we cover scalability 100%. So we cannot say that if the number of users increased from 10 to 1 million, that the performance will be the same. Logically, it cannot happen. But we try to be more and more scalable. Okay? And the way we do that is by having hierarchy of service providers that have more and more resources, and for you as let's say as QU, if the number of students at QU is in the range of 5,000, then I need this much resources, so I will talk to Ooredoo and get this much resources from their network, so which is tier 2 service provider. So Ooredoo is a tier 2 service provider. So I tell them, okay, I need to establish an agreement to get more resources from your network. Okay, and then if the number of users increase even more, then Ooredoo themselves, they will have a problem. So the number of population in Qatar has increased. So Ooredoo can ask tier 1 service provider like AT&T or Verizon to get more under marine cables and stuff like that, which is what we have nowadays. We have more than one line that goes under the Gulf or under the ocean and stuff like that in order to get more and more resources from the internet. So if we increase the number of resources in the network, then the more users we have, the performance will not be affected that much. That's what we refer to as scalability. So scalability refers to the fact that the network will be able to support growing number of users without degrading the performance. Okay? Because I can say, I can support millions of users, and then I have 1,000 users, and the performance that these users are getting is terrible. They cannot watch anything on YouTube. They cannot even send emails. They cannot do anything because their performance is very, very slow. That's not scalability. So scalability talks about supporting growing number of users without degrading the performance. مفهوم? Okay? Without degrading the performance, without reducing the performance. Okay? So the performance that these users are experiencing should not be low, okay? Or should be the same, more or less. طيب. Quality of service. Quality of service, the best way to understand it is to get the analogy between quality of service and discrimination. Quality of service talks about discrimination, but in a good sense. Quality of service talks about the fact that the network will tailor its resources to provide different experience to the different applications based on each application's requirement. So, example, we're talking about video applications. As we said, video applications, usually they are very much delay sensitive, right? So when we stream video from YouTube, we expect the video to play continuously. If there is any delay, degradation in the delay, what will happen? The video will start to pause, and buffering, all you get on the screen is buffering. And then after like certain time, you get another scene for 1 or 2 seconds, and then buffering. So what you will feel as a user, very bad experience. You don't want this to happen, right? So what will happen if I browse the internet? So when I click on a link and I wait for 2-3 seconds, not a big deal, right? As long as I get the page at the end, it's okay, right? And then you click on a page, and then you get the page after 2-3 seconds, it's okay. So you don't need to send huge amount of information continuously for a long time. That's what I'm trying to say. For web browsing versus for video, you need to send huge amount of information in real time, continuously, for a long time. And that's a big challenge for the network. So quality of service talks about the fact that the network is able to discriminate between each type of application. So if I have a video application, I should give it more priority, okay, compared to, for example, audio application, or compared to web browser. This is not easy to do. So if we look at the network from inside, so you have a user, okay, and this user is connected to a router, and this router is connected to the internet. And you have another user here. So this user is generating video traffic. This user is doing web browsing. Okay? So this traffic and this traffic is coming to the router, and the router is putting all this information into what we call queues. That's how the routers actually serve the incoming traffic. If we zoom into the router, that's what the router does. And then it stores this traffic into queues, and then it does like a roundabout. It say, this packet should go here, this packet should go here. That's what it does. If you look at the video that I posted on Blackboard, this is exactly what the router does. Okay? So quality is...
Like the printers.
No. Printer does not do routing. This is routing. Printers do not do routing.
Yeah.
Printers, they print based on priorities, but they do it differently. So for routers, I need to discriminate between these types of applications. I need to say, okay, since I have video and web browsing, video definitely have a higher priority. So I need to send it first. So I will get video before the web browsing traffic. Even if the web browsing traffic is coming first, once I see video, I should give it higher priority and send it along before the web browsing. What this will give the user as experience is that the user who is video streaming, he will feel that the traffic is smooth. The person who is web browsing, he will not feel that much degradation because the interaction with the video browsing, with the web browsing is usually low. You click on a link, you get the page. After some time, you click on a link, you get the page. So the interaction is low, So if you get some delay, 2, 3, even 5 seconds, you tolerate it. As a user, you tolerate it. So quality of service, again, talks about the ability of the network to be able to tailor its resources based on the type of traffic and the type of application that's coming to the network. Okay? So quality of service is all about differentiation or discrimination. Okay? So time-sensitive communication, we should increase the priority. We should have higher priority. Non-time sensitive communication, we decrease the priority. So we have some prioritization. Sometimes this priority is not necessarily coming from the type of traffic. Maybe it's coming from the type of user. If you are a user who is paying for a 100 megabit per second plan, I should not give you the same resources that I give to one who paid less and he has a plan of 1 megabits per second, right? So I should give you more priority, because otherwise, what is the use of paying more? Okay? So from the service provider's point of view, quality of service optimizes the cost effectiveness, right? If you pay more, I will give you more resources. If you pay less, I will give you less resources. If we don't have quality of service, what will happen? I will divide the resources equally between all the users and between all the types of applications. And that's what we used to have a while back. And that's why we could not support, like, for example, video or audio chatting using Skype over the internet. That did not exist. You cannot do that. Why? Because there is no quality of service. But if I know that this is a Skype voice chat, I should give it more priority, and this is web browsing, I should give it less priority. Both users will be happy, right? So I actually optimize the use of resources on the network, and I actually maximize the user experience. If you pay more, you expect to get better experience. That's what you're getting. If you pay less, you expect to get reasonable experience, but not as high as the other user. That's what you're getting. So it's a discrimination in the good sense. I give each application and each user exactly what they require and what they have paid for. And that requires, as we have drawn now, that requires some intelligence on the routers, which did not exist before. So, the quality of service is the main ingredient that facilitates the fact that now we have triple play, we have internet at home, and everything on the same connection, right? So we have communication at home, we have routers, we have machines, and at the same time we have the triple play from Ooredoo. So we watch TV over the same internet connection, right? And we operate with different types of applications, video streaming on YouTube, and we can YouTube on the TV, we can YouTube on our devices. So we don't actually feel that much different. So you can work on any device, you can work on any service, which uses the same infrastructure. All these services, they use the same infrastructure of Ooredoo. And that requires very high level of intelligence from that infrastructure, from the routers. The routers have to be very intelligent to schedule very accurately based on certain criteria, based on priorities, what is the type of application, how much this user paid, and so on and so forth. So optimizing the resources of the network to maximize the experience of the user. This is what quality of service is all about. And that has to happen through discrimination, but discrimination in a good sense. Okay? Then I have to be fair. I have to divide. And that's, yes, I have to divide.
Even if I have two routers in the same connection and they have 4 users.
That's another level of intelligence. So the routers have to be intelligent. If I have high priority traffic here and here, then I can probably load balance, which means that I send this traffic over this path, I send this traffic over this path, and I know that this path and this path, they will encounter the same delay more or less, right? The router is very, very important to provide quality of service. All the intelligence is in the routers. Very high level of intelligence.
تتدخل هاي في البروفايدر ولا بالراوتر
لا في البروفايدر mainly طبعا. Well, there is some stuff that you can do at the edge network which will prepare your traffic to be transferred efficiently on the core network. But most of this work is on the core network, on the service provider level. Okay. Huh?
Not on the router.
On the router. هو السيرفيس provider has ايه؟ ما هو has routers. But here we're talking about enterprise routers, the large scale routers, because here in the university we have routers, and there is quality of service built into these routers. Routers have levels. They have consumer routers, enterprise routers, very high scale routers, and so on. Okay. Security, of course, we all know security. Security has different levels. You can provide security on different levels. You can have data encryption. So you can have data encryption. Encryption means that you encrypt the data so that it would be hidden. And that's one thing that you need to have if you were to use VPN and provide private communication. You need to have encryption, of course. You need to have access policy, and that's also important. If you need to have private communication, you need to make sure that the user who is accessing this information is really eligible, and he or she has the privilege to access this information. And so on. You have firewall to block any kind of attack and so on. So there are different levels of security that needs to exist into your network. Some of these levels will be important for different types of businesses and different types of networks. For example, in our home network, usually we don't have that high level of security, right? We are not actually very much strict in terms of applying these security techniques. But when it comes to like organization like UU and things like that, we have higher level of security. When it comes to Uridu, we have even higher layer of security, and so on. Of course, security, we cannot cover security here. There are many courses for this issue. So the changing network environment, we talk about the dynamics of the internet, and for the dynamics of the internet, you have other types of features which are also, these are like new trends that are really emerging nowadays because of the Internet of Things and these new trends. So there is a concept of bring your own device. We are seeing more and more proliferation of online collaboration tools. So now we have WhatsApp, and we have Facebook, and we have all of this. Even video, we are seeing more and more video communication. Cloud computing is a totally new trend that happened just a few years back. So bring your own device is a concept that talks about the fact that whatever device you have, we will tailor the content based on your device. So, for example, if you have a cell phone and you do web browsing, the content that you get is different if you compare to the fact that you do the same browsing on your laptop, right? So this requires what? This requires the web servers have to be more intelligent now, that they check the type of device. So you bring your own device, but we will tailor the content based on that. So maybe you are watching a video on YouTube, but YouTube will detect the type of device and will give you lower quality of video because they know that you are watching this on a smaller screen. So automatically, we will tailor the content based on the type of device that you have. Okay? That's another level of optimization that the network needs to support. By network here, we mean the servers, even the resources on the network, and so on. Okay? So bring your own device is a concept that tailors the content, and the content, of course, affects the transmission over the network, because if we are transmitting over the network, small content is different from transmitting huge amount of content, right? So if we know that this cell phone, YouTube, lowers the quality, the amount of video that you get is less. So this is bring your own device. Online collaboration is one of the most strict type of application that requires very high quality of service. Why? Because it has both interaction and delay sensitivity. So the interaction is high, and the delay sensitivity is very high. So you actually communicate using voice and possibly video, right? So you have real-time streaming of video and voice, and at the same time, you have very high level of interaction between the users. So I need to talk, and the other person listens. And all of a sudden, we switch. He will talk, and I listen. So the video information can go either way. So I need to provide delay sensitivity on both directions. And I need to be very customizable to the direction of communication. So this requires a very high level of intelligence from the network to provide quality of service in both directions to facilitate this interaction and delay sensitivity on the content. And because of the fact that we have this in place now in the routers, and the routers are more and more intelligent, now we can have voice chat, we can have video chat over the internet, which inherently the internet, remember, the internet is packet switched network. So all the packets, they can go through different routes. So the internet is itself dynamic, and each packet can go to a different path. So how can you make sure that with this level of undeterministic behavior for each packet, that overall you get consistent performance for the users who are video chatting or voice chatting? This requires very high level of sophistication in the internet. Okay, so this is the online collaboration, and we have, of course, different tools to do this. We have WhatsApp, we have YouTube, we have Skype, and we have Windows Messenger. Many of these online collaboration which facilitates this type of communication. Video communication, and here we mean like video streaming. So we have delay sensitivity, but we don't have that level of interaction. So you are streaming a YouTube movie. The interaction with the YouTube movie is low, right? It's different from video chatting. So the interaction here is high. For YouTube video, every now and then you can pause, you can play, you can rewind. The interaction is not that much. So video communication has always been, and I think it will remain, the killer application of the internet. So if you were to zoom in on one pipe at a tier 1 service provider and look at the traffic, chances are you will find that maybe 80% of this traffic is video. And the 20% is everything else, our emails and our text and so on. Okay? So video increases in terms of demands exponentially over the recent years. It's increasing exponentially, and you cannot stop that. So now we're starting to have high definition TVs, and starting to have triple play and so on, and every day we have higher quality of video, and we have more services that requires video and so on. So video communication is also very challenging for the internet. Cloud computing talks about the ultimate flexibility of any organization to be able to utilize its resources as if it's one unit. So cloud computing here talks about the fact that if you have a group of very low-level devices, okay, so you have very small CPUs, very low speed, and you have thousands of these machines, okay? Can you perform very sophisticated type of computation on these machines? Probably not, because you will try to utilize each machine separately, and what each machine will give you is not that much, because each machine is small. It has very low capabilities, so you cannot do much with this. Cloud computing talks about the fact that you can actually integrate all these very low-cost machines into a cloud to act as one unit. Okay? So the way they invented this is by developing a virtualization layer on top of all the machines. This virtualization layer is like you can think of it as a new operating system, okay? That it integrates all the resources underneath so that you can see it as one unit. You don't see multiple machines. You don't see thousands of machines. You see one humongous machine. That's it. And this virtualization layer, it actually handles all the computation for you. So, for example, if you have a very, very sophisticated type of computation that you want to do, you send it to this layer, and this layer will do what? Will fork, will parallelize to all the machines at the same time, and will give you the answer right away. So you as a user, you are actually interacting with the cloud as one unit. But the cloud itself could be thousands of components. Each of them is like very, very small. Okay? So in the past, this concept was attractive because we can bring our old systems. You can actually build a cloud with, like for example, 10 very old machines. You bring 10 machines, which otherwise you will throw away, right? So you can bring these machines and put a layer of software, like an operating system, on top of these machines, and all of a sudden, these 10 machines are integrated into one very large-scale machine. You can do that very, very, very cost-effective, using the concept of cloud computing. So you integrate all the resources. So instead of having 1 megabyte on 100 computers, you have, or 1 gigabyte on 100 computers, you have 100 gigabyte on one computer. You see 100 gigabyte on one computer. You don't see anything underneath. So you can store, your application will be able to store 100 gigabytes of information in this RAM. And this virtualization layer will handle everything for you. So this concept is very attractive because now I can have an infrastructure, millions of machines, and that's what Amazon has, okay? And they can give you this infrastructure as a service. So you want a machine with 100 gigabyte, this much, this much, this much. I send this request to the virtualization layer, and the virtualization layer will build this. 100 gigabytes means that you want 100 machines, all of them integrated into one machine. I'll do that, I'll generate it for you, and I give you access to this machine. You want Windows on it? Fine, I will put Windows. That's it. So in minutes, you have built a machine with whatever requirements you want. You build it for some time, you use it, and then you dismantle it, somebody else can use it. It's a beautiful concept that did not exist before, and it actually optimizes the use of resources for any organization. So I don't have to have very sophisticated workstations all over my business office. I don't need to have that. I can just have iPads or something like this, and everything will be on the cloud. All the data, all the computation happens on the cloud. Okay? And today I provide service for 100 users. Okay, I need a machine with this requirement to provide service to 100 users. I build a machine with this requirement. Tomorrow, the 100 users have become 1 million users. Well, all I need to do is just send another request to Amazon. Now my machine needs to be bigger. They will build that machine for you. How do they do it? They do it through integrating more and more GPUs or CPUs and stuff like that, that virtually will appear to you as one unit. And this integration happens on the computation level, CPUs, on the memory level, on the storage level, hard disk, everything. They can integrate storage, they can integrate memory, they can integrate CPUs, and so on.
But they don't integrate the network itself, or they integrate one server.
Bravo عليك. Okay, so this is good idea, but where does network fit into this picture? Well, the network fits in the way that you integrate these machines, because in the back end, these machines are integrated using switches and routers. And
It's going to be slow to access.
slow?
Yeah.
It depends on the type of network that you're using. You can use very high scale routers to communicate between the machines. So it will look like this if you're not visualizing what we're talking about. As a user, as a business entrepreneur, for example, I have a requirement to build a machine which does not exist as a standalone workstation. It does not. I need a machine with 1,000 gigabyte memory, with 300 terabyte drive, and so on and so forth. There's no such machine that exists, or there is no such requirement exists in one workstation. So I sent to Amazon, and Amazon will get my request to build this machine. Amazon has an infrastructure which is very high sophisticated servers, millions of these servers, okay, which obviously do not exist in the same geographical place. It's distributed all over the world, okay? And these are connected using routers and switches and things like that, okay? So the request comes in. This guy wants to build that humongous machine. Okay, I will integrate these machines together, connect them with high-speed routers and switches, so that all of them will appear as one cloud, okay, to be used by that user for that period of time.
If it's going to access it, it will be slow. And even if the 5 computers are connected very, very fast network, to access them, it will be very hard.
No, access is dictated by the access method that you use. If you use DSL, or if you use fiber optics, then it will be a very, very high speed. Why do you think it's very slow? Why do you think it's slow? You will not pay for a cloud with this level of sophistication, and at the end you use a phone line DSL to access it. It doesn't make sense. You must be a rich guy to be able to pay for all this cloud, and yeah, very fast connection. Of course, you have a leased line with very high speed and so on and so forth.
It's the same idea.
But the idea is, you see this cloud as one unit. You can use it as one machine. You can store 100 terabytes as one unit. One database have 100 terabytes.
Storage will be divided.
The storage physically is divided, but you don't see this division. There is a virtualization layer here that does everything. For you, everything is virtually one unit.
But do you feel it, Dr. Why?
You don't feel it at all.
If you compare the speed of one CPU to 5, if I store 100 gigabytes on one CPU and 100 gigabytes divided over the access one CPU.
You will not be able to compare because you don't see that multiple. For you, it's just one machine. But if you were to do that experiment and you do it on multiple machines and you connect each of them individually, okay, and then build one cloud out of them, of course the cloud will be much faster. But much faster, why? Because you have to communicate with each one individually, and you have to compute the job individually on each machine, and you have to manually integrate all the results from all of this. Will take a very long time. The cloud will do this for you in a very optimized and fast way.
Doctor, let's say Amazon have the same configuration. The computers are 100 gigabytes. Imagine I want only 10 gigs, and another user wants another 10 gigs.
Yes.
Another one can.
You requested.
All of us use this one computer.
Yes, yes.
And we see it as separate computers.
Yes, yes. As long as, well, supposedly Amazon does not give the same physical resource to multiple users because you're paying for it. But maybe one of these servers have, let's say, 5 terabyte drive. You require 2. They will not waste the other 3 or 4. Okay, they will give you 2. So they will give you part of this machine. You see it virtually as one machine. And then another user will get the other 3. But I cannot say this 2 terabyte is used by this user and this user and this user and this user. This does not make sense because you are requesting, you're paying for it. So this is the concept of cloud. And there are big words here that talks about agility and rapid deployment. Rapid deployment here talks about the fact you don't have to buy physical machines. You just submit a request to Amazon, build whatever machine you want for that period of time. You do all the business that you are doing, and after that you don't need it, okay. They will dismantle it, they will build another machine for another user, and so on. Your business now requires this much, okay, we'll give you this much. Tomorrow, the number of users that you are serving increases exponentially, 1 million or something, okay, we'll increase the resources. You are paying, instead of paying like $100 per month, you will pay $200 per month, and it will give you the resources that you want. So this is a very, very beautiful concept. And because of this concept, we don't have to throw our machines away. We can just reutilize it, recycle our computation capabilities.
So if I have a large executable file that doesn't only fit on one hard drive, on one machine. So if I have like 2 servers,
yes.
So some parts of this executable will be on one hard drive on one server, and the other on another hard drive.
Right. Physically.
Yeah.
Physically, yes.
So
what you will see is 1 unit.
Once you execute it, how does this work? I mean, how do you manage at the instructions level? How do you share that on the CPU?
This is the function of the virtualization layer. The virtualization layer, very, very low level. This is the invention of. This is the, in my opinion, this is the core ingredient of cloud computing. This virtualization layer.
So they all have
you give it the request. I want this much file to be computed and analyzed and so on and so forth. The virtualization layer will know exactly where this file is on the physical machines, and will process the information for you, and then it will give you the result, one result from the analysis of all the file, even though the file is distributed amongst multiple machines. You don't see that. The virtualization layer will do that.
They all need to be on the same architecture.
Yani,
if I have one server with a Intel processor and one with
yeah, it doesn't matter. It doesn't matter. It doesn't matter.
What about the binary file? Binary file. I mean, I said an executable, so it's a binary, to be more specific. So how can you run it on Intel or what's going to be
well, that's what I'm saying. You have a machine which is integrated from multiple physical machines. If you want Windows operating system, they will select the right physical servers for you to be able to install Windows on it. Okay, and you integrate multiple machines as one unit. Now, if there is a different architecture, for example, non-Intel, then they will not select these servers and install Windows on it. They will install, for example, Apple OS on this different architecture. But they will not install Windows on a non-Intel architecture, or they will not install Apple on an Intel architecture, even though it's now you can do it. That's what I'm saying is they have these millions of devices, and they can select whatever devices they need to integrate together to give you with a virtual machine that you want using the proper architectures. This is internal. For us as a user, what we need to do is we need this much resources in this machine. They will build it for you virtually. Internally, what do? They select the proper architecture, they select the proper operating system, and put the proper software on this machine. And the good thing is that everything is timed. So you use it for that much period of time, and after that you dismantle it. Security in the cloud is a very big topic, huge topic. Yeah, I mean that requires another. So that's the concept of cloud computing, and that actually opened the door for many applications like smart homes and power line networks and stuff, which are not. These are not very important, yani, but maybe we'll cover it next time, inshallah.